We're asked to prove a trig identity to start off this question. Now we can either start from the left-hand side and get the right-hand side, or vice versa, or sometimes you play around with the left-hand side, play around with the right-hand side, and show that they're equal to one another, but you've kind of changed both. As long as you can get the same thing, then you're okay. So you're going to have to start with one side either way, and I'm going to start with the left-hand side. The reason being is that it tends to be easier to subtract things or add things than have them multiplied and then kind of bring them out to a subtraction. So the left-hand side is going to be 1 over sine theta, that's cosec, minus sine theta. And then I'm going to now put them over a common denominator. So it will actually be 1 over sine theta minus sine squared over sine theta, or 1 minus sine squared over sine theta. I've just done the subtraction all in one go. Okay, that doesn't quite look like what I want it to at the moment. I've got a sine divided by sine theta, but we can now use the identity that 1 minus sine squared is cos squared. And suddenly the cos has, we can see where it's come from. Because 1 is equal to sine squared plus cos squared. So I've just rearranged that formula. And now I'm going to rewrite it as a fraction. So cos theta over sine theta multiplied by cos theta. And we're basically there because I've got cot theta times cos theta. Let me just add up here that cot theta is cos theta over sine theta. And that is what I wanted, just in a different order, but that's absolutely fine. That is the right-hand side. Hence, or otherwise, solve for 0 to 180 this trig equation. Well, I'm definitely going to use the hence because that will allow us to take the left-hand side and straight away, using part A, replace it by cot x cos x. So that is equal to cos x cot 3x minus 50. There's two ways to approach this next bit. You can either just say, right, cos x, I can cancel it out, but I must consider cos x equaling 0. Or you could subtract one term from the other and then factorize out the cos x. Because now we've got it equal to 0, it must either be that this is 0 or this is 0. And ultimately, whichever way you go, but this way, like people sometimes forget that is a solution, but you can see it as a solution. If you put cos x is 0 in there, you get 0 equals 0, which is true. You must make sure you get it somehow. And our alternative is that cot x is going to equal cot 3x minus 50. I'll deal with that one in a minute. Let's deal with the cos x equals 0. So to be honest, you can just do inverse cos of 0. You're going to get 90 degrees. If you draw the graph, then you'll see that cos is 0 at 90 and at 270. 270 is outside the range. If you use chaos diagram, you get, again, 270 by doing 360 minus 90. But this is the only solution in the range. That leaves us with cot x equals cot 3x minus 50. Well, I could swap that round to tan x. You normally do that with reciprocal trig, try and get it back in terms of normal trig functions. Or should I say the standard trig functions. Now, if we do inverse tan, we're basically going to get rid of this, and that would give us x equals 3x minus 50. That's definitely going to be a solution if, well, assuming it's in the range, when these two are exactly the same. That leaves us with 2x equals 50, so x is 25. Okay, so we've got two solutions so far. It's just whether there's any more. Now here's the graph of tan x. But for example, tan 40 is equal to tan 220 because tan is periodic about 180. So I'm just adding on 180 and I'll get exactly the same value. And so we must take that into account here as well. When in the process of doing inverse tan, it would kind of come out. So it could be that x is actually 3x minus 50 plus 180. Actually, that would make this one here the x, and this one here the 3x minus 50. What happens in this case is I get x equals 3x plus 130, and then 2x would be minus 130. Okay, I'm going to get x is minus 65. This is not in the range. But what if instead, so I can just ignore that actually, what if instead I did x equals 3x? And if I add on any more 180s, they're just going to get more negative. But 3x minus 50 minus 180, using the same sort of idea, I'm just, saying that two different values of x can give the same value of tan. Tan is periodic about 180, so I'm minusing 180. Now I'm going to get 2x is equal to 230, and then x is going to be 115. And we can check that. If you want to put it back in, you can put it back into cot or into tan. We're going to get tan 115 on the left-hand side, and then on the right-hand side, times by 3, we're going to get 345. And then if I minus the 50, I'm going to get 295. And that is true. You can put it in your calculator to check if you like, but you can see I'm just adding on 180. It's going to work out. Okay, I guess all we need to do is just see if there's any more solutions, because remember it was 0 to 180. But then I'd be minusing another 180, so 360 overall. That will give 2x is equal to 410. So the next one is going to be 205, not in the range. So our full answers are going to be x equals 90 degrees from the cos x equals 0, 25 degrees from setting x equal to 3x minus 50. The one that quite easy to miss, but make sure you don't. Basically, practice these. If you've never seen this before, then it's going to be awkward for sure. But just practice some more with sine and cos and so on. These are three solutions.